The intake manifold piping includes 2 pipe clamps, 2 sealing O-rings, the intake manifold cold air inlet pipe, the turbo compressor hot air outlet pipe, a mounting bracket, and the intake manifold hoses. The rocker cover is a one-piece unit that has a built-in oil separator system at the front. A one-piece preformed rubber seal is used as a cover gasket and side seal. There is an oil drainback hole in the upper left-hand corner of the cover. If the engine is using oil, check this drainback hole to make sure it is not plugged. The structure in the left upper corner of the rocker is part of the oil separator. It houses 1 long and 1 short bundle of wire mesh. 7 Allen head bolts along the center line of the rocker cover hold it in place. A one-piece exhaust manifold is used on the 904, 906, and 924. The 926 versions have a 3-piece manifold, which is assembled before installation. Both versions of the exhaust manifold are cast iron units. The pre-2004 manifolds use 3 separate steel gaskets that seal 2 ports each and are connected by a bridge. The bridges are labeled top. These gaskets are installed with the bridge up except on the front ports. The gasket on the front ports is installed down so that it will not interfere with the bolts used to secure the brackets for the charge air piping. The manifold is secured to the cylinder head with Torx bolts, which require proper length measurements before they can be reused. The 2004 900 series 6-cylinder EGR exhaust manifold incorporates a divided chamber that separates the front 3 ports from the back 3 on the 6-cylinder engines. The front section of the manifold supplies EGR flow from the 3 front cylinders. There is no divided chamber in the 4-cylinder engines because all cylinders provide EGR flow. A 90-degree exhaust elbow with multiple steel rings for sealing at each end is also used to direct flow. Another flanged elbow with a heat shield is bolted to the lower EGR cooler. The acronym EGR stands for Exhaust Gas Recirculation and describes what happens in an EGR-equipped engine. With an EGR system, a measured amount of cooled exhaust gas is directed back into the combustion chamber. It dilutes the oxygen content of the fresh air flowing into the combustion chambers, reducing the peak flame or firing temperature. This dilution of the oxygen in the combustion chamber results in lower temperatures and pressures, causing lowered formation of nitrogen oxides, or NOx. EGR systems were developed in response to government regulations controlling the release of nitrogen oxides, or NOx, and other particulates into the air. EGR systems have contributed to a 90% reduction in these emissions over the last 20 years. The EGR system on the MB900 is made up of a number of components that we will discuss individually. EGR control operation. Full flow EGR occurs during normal operation when the coolant temperature is above 158 degrees Fahrenheit or 70 degrees Celsius. It does not flow at idle. Reduced EGR flow occurs when coolant temperatures are below 158 degrees Fahrenheit or 70 degrees Celsius at engine speeds above 1500 RPMs to protect the engine and turbo under smoke protection mode. No EGR flows when coolant temperatures are below 65 degrees Fahrenheit or 17 degrees Celsius, or for condensation protection. EGR does not flow when the intake manifold temperature exceeds 212 degrees Fahrenheit or 100 degrees Celsius for engine protection. EGR also does not flow during engine warm-up when coolant temperatures are below 158 degrees Fahrenheit or 70 degrees Celsius at low speed or low load for engine protection. EGR will not flow at low speed, high load conditions because the difference between exhaust pressure and boost pressure is not enough to cause EGR flow. Additionally, under these conditions, engine performance would be poor because the turbo could not attain appropriate speed fast enough. EGR system failure results in 20% power loss. The EGR rotary valve performs a self-clean during engine braking and after engine shutdown. The reed valves perform two operations. They provide for exhaust gas flow into the intake air system. They also prevent the loss of boost pressure during high load conditions. Essentially, the reed valves are one-way check valves that allow exhaust gas flow into the air intake system. The reed valves open when exhaust gas pressure is higher than boost pressure and close when boost pressure becomes higher. The Charge Air EGR mixer is a one-piece cast aluminum unit. It houses a removable mixer pipe and optional grid heater. When a grid heater is not present, a block-off plate is used to seal the cavity. An O-ring is used to seal the intake manifold end. A metal gasket is used between the mixer and the EGR temperature sensor housing. The front 3 cylinders on the 6-cylinder engines and all 4 cylinders on the 4-cylinder engines supply exhaust gases for EGR. They are routed through the 90-degree exhaust elbow, flow into the flanged elbow, and then into the lower EGR cooler at approximately 600 degrees Celsius or 1112 degrees Fahrenheit at rated power. The exhaust gas flows from the lower cooler through the rotary valve into the upper cooler. It then flows into the engine at temperatures of approximately 140 to 150 degrees Celsius or 284 to 302 degrees Fahrenheit. The EGR rotary valve regulates the flow of exhaust gases from the lower to the upper EGR cooler. It is controlled by the ECU with valve positions ranging from 5% considered closed to 85% considered wide open. Built by Waller, the valve has 4 connector pins, 3 of which are used by the ECU while the 4th is for diagnostics. The rotary valve is not serviceable and must be replaced if malfunctioning mechanically or electronically. The EGR cooler must be removed from the engine to replace the rotary valve. Exhaust gases drive a turbine and compressor wheel inside the turbo. The turbo compresses the air going into the combustion chambers. Compressing the intake air allows more of it to be forced into the combustion chamber and, by demand, more fuel as well. Greater volumes of air and fuel mean more power from each stroke and the engine in general. Before 2004, 900 series engines of less than 250 horsepower had turbocharger assemblies that were non-wastegated. They had an optional air-operated exhaust flap that was controlled by the ECU. The 2004 and after turbochargers on the 900 series engines all have non-adjustable wastegates. The entire turbocharger must be replaced if there is a problem with the wastegate. The actuator, CAN, on these units is checked by pressurizing it to 14.5 psi or 1 bar, spraying it with water, and checking for leaks. The 2004 EGR 926 and 906 engines use an asymmetrical turbocharger housing, which is also referred to as the double flute turbine housing. The front chamber of an asymmetrical turbo is much smaller in area than the rear chamber. The result is a back pressure generated in the front 3 cylinders of the exhaust manifold, which allows EGR flow into the engine. An engine brake flap assembly is operated by an air cylinder energized by the ECU through a 2-wire solenoid activated by the number 1 proportional valve. The brake opens or closes, working with the constant throttle valve for maximum braking. Increased airflow through the engine increases braking performance. The easiest way to check the position of the flap is to look at the position of the slot on the top of the splined shaft. The oil separator in the rocker cover consists of a diaphragm and diaphragm stop, a spring and housing which contains the wire mesh bundles, and finally the rocker cover itself and a preformed rubber gasket. The air compressor and power steering pump are separate units. The engine can be configured with the power steering unit or the compressor individually, or with both as one unit. The compressor is gear-driven by the camshaft and delivers 15.5 CFM, or cubic feet per minute. The assembly is located on the lower left rear corner of the engine block. Maintenance best practices. Regular inspection of all air system components is crucial to optimum performance of the system. Pipes, hoses, and clamps must be in good condition to avoid leakage and/or obstructions in the system. Regular prescribed filter changes are also important to the overall performance of the air system and the engine. Some possible causes of black engine exhaust are a clogged air filter or system, a malfunctioning exhaust brake, or a damaged charge air temperature sensor. The possible cause of white engine exhaust is a malfunctioning intake air preheater. Poor engine performance and mileage deterioration can be caused by a clogged air intake system or filter, a malfunctioning exhaust brake, a damaged or malfunctioning charge air temperature sensor. A non-start condition can be caused by a clogged air filter or system, a malfunctioning exhaust brake, or in extreme cold, a malfunctioning intake air preheater. The object of this exercise is to place each of the MB900 air system components in the correctly labeled boxes. If the component is placed incorrectly, it will return to the selection area for you to try again. Place your mouse pointer over the desired component, then press down the left mouse button and drag the component to one of the three descriptive boxes. Release the button to make your selection.